Yeah, so here's our implied return. Let's see how it renders. There it is. So 4 times 5. So it works the same, right? So as you would expect. Okay. So yeah, so definitely gives you the opportunity to be much more terse, much more compact, right, for the same amount of work. The other capability for being able to be compact, right, is also in the parameters, right? That if your function, right, if your arrow function only has a single parameter, well, the parentheses is not needed. You don't need the parentheses. You can drop the parentheses, right? And it understands that that is the single parameter to this function, right? Now, I don't like that syntax when it's used like this, right? I find it hard to read, right? I'm looking for those parentheses, right? But again, when you use this inside of a bigger expression, like a map, a filter, a reduce, right, and find or something, right, then these functions are embedded functions. They're lambda functions inside of these larger expressions. And so this compact syntax comes in handy. Right? So, but this gives you a chance to practice the syntax. So let's create the file, right? And we create the function, and we do the export. And so yeah, so here's a function that computes the square, right, of a parameter, and because it has a single parameter, right, the parentheses are optional. But my IDE is set up, right? It's using a linter, which looks for ugly code, and it makes it pretty, right? I'm using also a prettifier, right? Or prettier, I think it's called, right? Which, if I on save, it'll make it prettier, right? So it adds the parentheses when I save to the file. So yeah, so because of these two have a single parenthesis, a single variable, I could drop the parentheses, right? So let's do a return here. And there we go. And then we can display it. Function parentheses and parameters. And then there it is, right? It just works as expected. All right, question on the chat. How about, is it possible you to give us an example of the implied return in a complex situation? Yes, when we get to find or map, index, which we'll see in a minute. Now that we're going to go into arrays, you'll see examples of using those functions, right, inside of arrays. That's why I'm introducing the syntax first, because I'm about to use it in the arrays. Yep, we'll do it in a minute. Actually, this is a good time to take a break, and we'll come back right after these messages. All right, and then we'll talk about arrays. All right, let's continue. All right, so yeah, so let's talk about now working with arrays, right? And this is where the some of the new syntax in the arrow function is going to come in real handy, right? So yeah, like any other language, obviously, the JavaScript can work with complex data structures like objects, arrays, and whatnot. So let's take a look at arrays first, right? So yeah, so let's declare a few arrays, right? And then we can play around with some features of the array data type, right? So let's create arrays. Let's create a function, and let's export that. Let's declare a few arrays. So let's copy them and let's paste them in here. like that. So yeah, so you can create arrays out of integer arrays, number arrays, strings, or you can have arrays that contain a mixture, right, of variables of any type, right? So you can mix and match strings, booleans, integers, other arrays that contain other arrays that contain objects of arrays of objects. So you can create arbitrarily complex data structure, right? So let's display them here. So return, and let's see if my AI can come up with something, and then let's bring that into my JavaScript exercise. So working with arrays, right? And so there we go. Oop, where's my window? Where'd it go? There we go. Yeah, so there's working with arrays. So you have all these variables. Notice the array, right? So see how it's been rendered, right? So here where we are rendering the this array, number array here, when it gets rendered, notice that it drops, the square brackets, the commas, right? It just concatenates all the values when it gets rendered. Actually, that's very, very important, right? Because we'll see that this feature of arrays, when they get rendered, they just get concatenated as a one big string. That's a really important feature because if you have an array of components, of HTML components, and you try to render them, basically they get rendered as if it were just a single, HTML, concatenated string of HTML components, right? Without the commas. In last week when we were doing mapping and things like that, if you remember, there was this comma that sometimes would come up, and that's why we had to use a join, right? That would strip out all the commas, right? Well, here you don't have to, right? That's part of the feature set, right, of the language. Same thing here with the string array. Notice that it just gets strung into a single string when it gets rendered, right? It's a question on the chat. So is it a string or an array? So it renders as a string. So everything has to be converted into a string, right? Everything that is going to be rendered on the HTML document has to be convertible into a string, right? So like before, remember we tried to render the Boolean true, false, and it would not render. And the only way to force it was to convert it into a string representation, and then it was rendered on the screen. So yeah, so it is an array, but to render it, it gets converted into its string representation. So yeah, and so let's take a look at other exercises. We can determine the length and the index. I'm not gonna do this exercise. I'm gonna leave it up to you. How about this one? This one you can mutate arrays, right, by concatenating new content, right? So let's create a new file that allows us to adding and removing content to an array. And you can append it to the beginning or the end. Export. There we go. So here. So you can create the same variables as before, right? But you can add at the end of the array, you can append the value 6, the number 6, or you can append at the end string 3, right? And so if we render this, right, you have that, and then we can bring it into JavaScript. We have add arrays. Then they are. So notice that we've added 6, right, at the end, and we have a string 3, right? Now you can also bring it at the beginning as well, right? So you can use instead unshift, right? So for instance, if you say number array. Pop removes the last one, but what I wanted to show you was you can do unshift 0, so adding a new item at the beginning, right? Or you can add a string at the beginning, string 0, and there they are. See that the 0 is added at the beginning, and string 0 is added at the beginning here as well. See that? But you can also have a an array of HTML components, right? So if you say a const a list, right, where you have UL, right, and then you have so LI, right, that contains to do one, right, or do assignment 1, right, comma, and then LI assignment 2, right, and then comma. You save this, oops, and then close the parentheses. Basically, it's an array, and notice that it gets already the IDE renders it, adding the spaces, right, the white spaces, to understanding that that these are somehow related to one another, right, nested inside of each other. And then you can render, right, the list, right, and it renders as a string. Okay, this time around it did not remove the commas. You would need to join and remove it, but we'll see that when we use the map function, right, it strips them out, right? So for instance, you can do a join, right? You can do a join with it converts it into objects. Okay, no. Let's do the map. We'll work on using the map to do these kinds of operations. You would not actually do it the way this way. You would use a like a map or reduce, right, to create these arrays of content, which is that example is coming up in a minute. Let's do loops. All right, so here's a simple loop. I'll skip this exercise. It's just looping like any other for loop, right, from beginning to an end to the length of a particular array, and this is just copying one array to the next array, right? All right, the map function. Map function is one of the most useful functions that we're going to be using all throughout the semester, right? It's going to be over and over and over. You'll see the map function everywhere, right? It's one of the most useful functions for building content dynamically. So let me just close some of these. So close others. So let me open up a file for the map function, and let's create the function here, function map function. Okay, and let's export, and let's grab it. So let's look at just a simple example first, right? So we have you have number array, right, with 1, 2, 3, 4, 5, 6, right? And here's a function. Here's a function where you do the square. And here's where the syntax of the very compact syntax comes in handy, right? I mean, we could have written this like this, right? This could have been function A that returns. This would be the alternative using the older function syntax, right? It's kind of quirky. You have a this embedded function that doesn't have a name, first of all, right? So it's a lambda, obviously, and so what the map function does, it calls your function for every single item, right, in the array. So it iterates over this array and calls the function, the parameter, calls it for every item. So it's calling it for 1, then for 2, then for 3, then for 4, 5, 6, right? And for each item, it calls a function, and whatever the function returns, okay, it accumulates all those results, right? So here squares, it's a new array, right, that gets calculated from the old array. And for every item in the old array, you have a new item in the squares, right? And what are those values? Well, the results of all these function calls, right? So for instance, for 1, 1 gets passed, and then it returns 1 times 1. So squares now has 1. Then when it gets to 2, right, it passes 2, and then 2 times 2 is 4. So now squares has 1, comma, 4. And then 3, so 3, 9. So it's now 1, 4, and 9, right? And so on, right? So it computes an array of the same length as the original array, with new values, right, that are calculated by calling that function. So yeah, so this syntax is awful, right? So we could use a new syntax. The new syntax is that, we remove the function and we do an arrow, right? So already I'm saving a few characters, but because now I'm using this new syntax, I can, for instance, if I have a return that only has a single line, the only statement in that function is that return, right? Well, I don't have to. It's optional. I can remove the return, but I also have to remove the curly brackets, right? And in this case, I don't need the semicolon either. And there it is. So that long expression becomes these, very few characters that do exactly the same thing. So very compact. Or we already have a function that we declared up here, right? And we can just use that to call it. So it calls that function for every single one, and it calculates a new square. Right. So this is using a function that was declared, whereas this is called an anonymous function, a function that doesn't have a name. See that? Meaning that this function here, because it has a name, it can be called from a whole different bunch of places, right? I can pass it, right? Somebody else can call it. It can be called from different places inside here. But this one, it doesn't have a name. Right? Because it doesn't have, we call it, it's anonymous. It doesn't have a name. It can't be called from anywhere except within the context of this map function, right? And so it only exists, right, within the context of those two parentheses as a parameter to the map function. And this one is doing what? It's calculating cubes, right? It's multiplying each item 3 times with itself, and it's calculating the cubes of the input array. Make sense? All right, so let's display that. We'll say return, so return. Let's see if my AI comes up with the values. Perfect. Let's display them here. So the map function. So map function. Map function. There we go. Let's see how that renders. There it is. So notice that this is the original array, right? 1 through 6. Right? And then the squares, right, are, 1 square is 1, 2 squares 4, 3 squares 9, 4 squares 16, 25, 36. Make sense? You have the cubes too, right? 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and so on and so forth. Make sense? All right. The other thing, what we could do instead, for instance, we could have a UL, right? And then within that UL, we could iterate over those values, right? You can say we can embed an entire expression here that calculates, instead of this cubes like this, notice that we're doing the cubes, rendering it there. What's it doing? It's an array, and it's concatenated onto a single string, removing the commas. Well, we could do that right here. We could do that again right here. We can embed and say number array. I'm going to map through it. And as I am mapping every single value, I am calculating a value that is going to return. Notice that there's no function, or there's no explicit return. So what is it returning? It's returning this li, right? So the result of this is a new array that has concatenated several LIs, right? Into an array of multiple LIs, right? And once it gets evaluated, it gets concatenated into one single thing, right? Into a single string with no commas. And if I save that, notice that there it is. See that? It returns the squares, right? The square of, right, A squared is blah, blah, blah. See that? So that's a dynamic list that we generated, right, from an array. Make sense? All right. Yeah, so let's see. So that's the map function. Now, sometimes we do want to display these arrays as proper, right, with squares and commas and whatnot. So we can convert it into a string representation before it gets pumped to the DOM, right? Its string representation being, you know, the object representation. The object representation is this. That's how we, you know, that is the string representation of you know, of all the characters that make up the string, that's including the square brackets, the numbers, the commas, right? And so there's a function that allows us to do that, right, to convert it into that representation, and that is the JSON stringify. So stringify allows us to convert, you know, complex objects or arrays and whatnot, right, into their string representation before they're even interpreted as DOM elements. Okay, and so this is very useful for, you know, for debugging purposes. If you want to, you know, pump to a screen an actual data structure, you want to see it right there as opposed to printing out to the console, right? So let's create a little component for that. So say new file, stringify, and let's create a function for this. And let's export stringify, and let's just copy a few things here. So we have a squares in here, right? And then we want to display this. So we'll say, you know, return. My AI will do that for me, I think, right? There we go. So we're going to call JSON stringify, which is going to display these squares, right? So we can bring that in here. So this is JSON. What is it? JSON stringify. Save. Oops. JSON stringify is not defined. Oops. Did I not? Oh, maybe I didn't load it. Didn't import it. So import blah blah. There we go. So notice that now it renders, right? It renders like a proper, right, array with the commas and everything. So this was converted into a string, you know, so that it would not be interpreted, right, by React.js, you know, as an array. Now it's being interpreted as a string. Okay, so it's not reinterpreted into, oh, I need to concatenate these into strings, right, and throw out the commas, throw out the square brackets. So first it converts into a string, and then it's just being interpreted as just a plain old string. Okay? So yeah, so this is very useful for debugging purposes, right? So for instance, if you want to, you know, it's very useful, for instance, to create maybe a little component, right, a utility component, call it JSON. Okay, I think we already called it JSON stringify. I'm gonna call it JSON pre. I'm gonna call it, and you'll see in a minute why. So I'm gonna have a function called JSON pre, right? That takes as argument, and so this is going to be the first time that we are passing an argument to the why there is no .js suffix when you import the file. Yeah, we discussed that at the beginning of the class, right? We said that if it is optional using the .js, and if it's a folder that has an index.js, right, it loads the index.js, you know, without you having to specify. So yeah, so it's optional in React.js. You don't have to. That's why, you know, last week when we were using import, my IDE was insisting to remove the .js, because it thought we were coding in React, right? But we were not in React, so we did need the extension .js, but not here. It's not needed. All right, so here we have we have some JSON that we're going to pass in. Some JSON. It's an object. It's an object, and we're going to return. There we go. Yeah, very good. Good AI. So I'm returning a pre. Pre is a tag that pre-formats in using Courier, right? So it doesn't embellish it using a fancy fonts or anything like that. It's for maybe code that you want to display, right? And you want the literal representation of the texts, right? You don't want to embellish it with sans serif or anything like that. So just with plain old Courier fonts, right? So it creates a pre-formatting. So where you have the spaces are literally going to appear in there. So if you have tabs and things like that, which normally would be ignored by HTML, right? Any white spaces, any new lines, any tabs, but pre literally interprets that and keeps all that formatting, white spacing, right? And then here we have JSON stringifying whatever you pass it, and then you can pass it, that you can prettify the code by adding tabs or spaces, extra spaces, right? So that if you pass it code or if you pass it JSON objects, right, it'll format it so that it's readable by a human being, right? So if I go back into my example here, I can in squares I can pass as arguments, right? Let's put a break there, and we're going to do JSON pre, right? I'm going to pass it as arguments, the squares, all right? And notice how it renders it. See that it renders with square brackets and every one item separately in each line, right? So this is actually a nice little tool that is useful for debugging, as we're going to start working with objects and arrays and complex data types, and you want to quickly pass it the value of a variable or an object, right, to see what it's doing, as opposed to displaying in the console. I mean, you can always display in the console, obviously, right? You can always do console, log squares, right? And you can go into the console and read it. But if you could print it right to the screen, right, it's much easier to debug, right? So yeah, so that stringify is very, very useful. So now that we've introduced stringify, we're going to be using it throughout, right, to display multiple things. Also, we just introduced the notion of passing parameters to one of these, because this is a function, right? JSON pre is a function, and I want to pass it arguments. So how you pass it arguments, using the tag notation, right? The XML notation where you use attributes and values for attribute. That's how you use it in HTML, right? Well, you can pass parameters to that function by using the attributes and values. Now, this is usually in HTML, this would be a string, right? But here, because this is not HTML, right? Behind it, there is a function. You can pass it references, right, to objects, right, or pass by value, pass by reference, and so the parameter JSON is going to have that value. So here's a parameter JSON. Also notice it has a little, it's surrounded by curly brackets. I'm going to talk about it, what that means in a minute. But yeah, so for this to work, you cannot just have a parameter like that, right? It has to be inside of curly brackets, right? And I'll discuss that in a minute why. Okay, but yeah, that's a great little tool for debugging. All right, so let's take a look at other functions like find. Find allows you to find items in a string, in an array. So let's copy that and just play around with it a little bit. Very, very useful. find. So let's do function find, and let's do export. There you go. And so there's two versions of this find function, right? One of them looks for the item in the array, and when it finds it, it returns the actual item that it found, right? So for instance, these finds take as argument, right, an arrow function. Well, it could be a old style function too, but it's interesting. It's much more compact and easier to read if you use one of the new syntax with an implied return, right? And even it would be even nicer if I didn't have to even put the parentheses in there, right? It would be even more compact, but my IDE is not going to let me. I save it and adds it back. So it takes as argument a function, a predicate function that, as you're iterating over each item, right, it passes it to the function. And if that function returns true, it stops, right? It says, ooh, I found it. I found what I was looking for, right? So for instance, what am I looking for? So what you do is that you provide the criteria for when the thing is found, right? So in here, for instance, if you're looking for 4, and this is a very huge data structure, and you're looking, you give it the criteria. What is it that you're looking for? I'm looking for the item that meets this criteria. What is the criteria? Could be anything. Here is as trivial as saying, well, it's whenever the item is equal to 4, right? Now, what does it return? Well, the item that caused this to be true, right? And so the and then we can assign that to a constant like 4. So 4 has the value of 4, right? If it doesn't find it, then it returns -1. So 4 would be -1 if it doesn't find it. Here we're looking for the item that has the value string 3. Notice the triple equal. Always use triple equal. Don't use double equal. And so when it finds it, it returns the item that caused it to be true. So it would be string 3. So let's display this in a return. Let's see, return. There it is. So let's include this in the script. So this is a find function. And let's display it. There it is. So here's the number array. Here's the string array. And number find blah, blah, blah is equal to 4, found the 4, and then it found the 3. Okay? You can also just ask for the index. Where did I find it? What is the index where I found it? So let's just copy that portion and let's use the same example. Okay, so let's so I can instead of having the actual value that caused this to be true, I just want to know where is it, what index. Okay. So let's see if I can create a couple more examples. The index, there we go. So found the index, and so does this display? There it is. So yeah, so it found it at index 3. So 4 is at index, so it's 0, 1, 2, index 3. Whereas string 3 is at index 2. So 0, 1, 2. So it finds it at index 2. Yeah. So another very, very useful function is the filter function, right? Filter function allows us to, like the name says, filter out certain things, right? That you might have a very, very big array, but you only want a subset of that array, only the ones that meet a particular criteria, right? So here, if you have the number array, right, and you want to filter it, for instance, we can create a few filters here. And so this one is, notice it's taking the number array here and it's filtering. What it does is it computes a smaller array from given an input array, which is number array. It calculates a smaller array, right? That includes the items that met the criteria, right? So for instance, I want only the items that are greater than 2, right? So it would come back with 3, 4, and 5, right? So numbers are greater than 2. So it would iterate over each one, checking to see which one is true. And if it's true, it keeps those. So 3, 4, and 5. So this would be 3, 4, and 5. These would be the even ones, right? The ones that modulus 2 is equal to 0, or the modulus 2 is not equal to 0. So it can calculate the evens and the odds, right? So let's print those. Let's see if my AI filter. There we go, right? And there we go. So notice that it comes back with the ones that are greater, right? The ones that are even. Oh, what about the other ones? All right, filter. Oops. There we go. Right. So those are the even and those are the odds. So my AI is kind of so even numbers, right? And these are the odd numbers. Odd numbers. There we go. Right. Okay. All right. Let's move on. Let's see. Okay, template littles. So template littles, we did use this towards the end of last week, right? To build our strings. It's a new syntax for strings that allows you to much more easily embed content inside of strings, trying to avoid the error-prone string concatenation. Concatenating string to build more complex strings is very, very error-prone. You should stay away from it, right? It's also much more compute intensive, right? It's very expensive to concatenate strings, right? But templates littles are much more efficient, right? And also it's not as error prone, right? And so this so let's create the template little. Oop, I guess I forgot a T here. So here's that function. And let's grab the body, right? And let's not forget to export, right? So here I'm creating, just a few values, some results, and typically you would have to concatenate, the strings, 2 plus 3, blah, 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 plus 5. This is how you would normally do it, right? Now, in the new syntax, what you do is instead use the single backtick quotations, right? So JavaScript has 3 quotations, right? It has a single quote, the double quotes, and those are interchangeable. You could use them, as long as you're consistent, right? You could use single quote or double quote, right? So this could be single quote. But I think my IDE, my IDE doesn't like single quotes. So it replaces them by double quotes, right? But they are interchangeable. Whereas backticks it's a much more powerful version of quotes, right? It allows you to embed inside expressions, right? You can say $, right? And then with the curly brackets, you can put in there computations, right? That as long as the whole thing evaluates to a string or can be converted or coerced into a string, you can put anything in there, right? So this is much more easier to read, right? And also less error prone. You're just working with one string as opposed to just like that. You can embed strings like Alice, so username Alice, right? Or you can embed entire expressions, right? That as long as it evaluates to a string, right? So here, for instance, logged in. Based on whether this is true or false, right? The whole thing either evaluates to yes, right, or evaluates to no, right? So this whole thing evaluates to yes or no, right? So let's return here, and let's render this. Let's see if my AI. There we go. Epiliteros, greetings, and let's include this in JavaScript. So this is template littles, and there it is. So logged in no, right? Evaluates to, because the Boolean expression was false, right? So this is false. It's false, so it renders that. If this were true, then this renders as yes. Makes sense? All right. All right, let's keep going. All right, so JavaScript object notation. So yeah, so JavaScript can work. Oh, there's a question. Yes, yes, no is already string. Why do we need the curly bracket? Yes, no, sorry. No, it isn't. What do you mean? So yes would be a variable, right? So this is inside of an expression, right? So these would be a variable called yes and a variable called no. So this would not compile and say, yes and no are undefined, right? So yeah, so this is either single quotes or double quotes. You use my IDE converts all the single quotes into double quotes, right? Yeah, so yeah, JavaScript can work with objects, right? And objects are built using the notation called JavaScript Object Notation, or JSON, right? And it's a curly bracket based notation, right, that allows you to group together multiple properties and values, right, separated by commas, right? So here you have a property called bedroom with value 4, right? A bathrooms value 2.5, and you can mix and match all sorts of data types, right? So you can have numbers, floating points, strings, other objects contained inside of other objects, or that contain arrays, that contain other arrays, that contain more objects, arbitrarily complex data types that include each other, right? So here's an object called house, right, that is being assigned, right, an object literal, right? Just like you have a string literal here or a number literal, right? You have an object literal, right? Literally an object, right? That is being assigned to house, right? And then you can use dot notation. You can use dot notation to read those values from that object, right? So let's play around with it, and notice it's using the JSON stringify to render it, right? Make it pretty. So let's create it here. Let's create a house, right? And let's we have the whole function here. Right, so here you have H2 with the house. You have the bedrooms. We're displaying the bedrooms and the bathrooms and so on and so forth, right? And then we're stringifying the whole house, right, to render it pretty so that we can read it, right? So let's include this in our JavaScript here. So this is house, right? And then we can render it there. See there, so bedroom 4, 2.5, or the entire JSON object, so you can easily read it, adding extra spaces, right? How many spaces? As many spaces as you have here, right? So you can make it more spaces. You can say 4, right? So it's more tab, so it has a more indentation. So this controls how many spaces you want for the indentation. Okay. So yeah, so we're going to be using JSON a lot, throughout the semester, right? We're going to represent all sorts of objects, right? And we're going to iterate over them, right? And convert them into some user interface. Yes. You can also, do all sorts of transformations, right? And combine objects into more complex objects, where, for instance, where you can copy objects onto other objects, right? And one of the complexities of doing that operation is that typically that operation is a shallow copy, right? That you only copy the top level properties. But in JavaScript, you have a notation that allows you to do a deep copy, right, of an object onto another object, right? You can insert objects instead of other objects, right? Let's see some examples. So one of the more important operators that we're going to be using throughout the semester is the spreader operator. So the spreader operator allows us to spread one object or one array onto another object or another array, right? So let's take a look at that. So let's take a look at the spread. So this is a very, very important operator, and you're going to see it a lot this semester, right? So let's copy that here, and let's go over this. So here what's happening is that we're declaring an array, 1, 2, 3, right? And then we're declaring another array that has its own values of objects 4, 5, and 6. And what we're doing is that we're spreading the array 1 that has 1, 2, and 3. We're copying those values, right, onto another array at the beginning of the array, right? This could very well be at the end too, right? We could put it, what happened? Save. Okay. We could have put this maybe at the end. That would have been 2. We could put it at the end or anywhere in the middle, right? We could have other values at the end, 7, 8, and 9. So you can put it anywhere in the array. It'll just copy those values from that other array onto this array. Okay. Same thing for the objects. You have one object that has certain properties with certain values like A, B, C, right? And then you can then copy, right, or spread that other object onto another object. Like for instance, here you have we're spreading object 1. So we're copying all those other properties, A, B, and C on here onto A2. So now object 2 will have not only its own properties, D, E, and F, but it have new properties, A, B, and C. Now the order typically doesn't matter, right? But when you're spreading, it does matter. You have to be careful, right? Especially because you could have duplicates, right? In an object, a property is unique. You can't have 2 properties with the same key, right? As opposed to an array, it's okay to have values, multiple times because the indices are unique, right? The indices are always going to be 0, 1, 2, 3, all the way to the length, right? There's no way around that. As opposed to an object, the indices, right, or the keys, you provide the keys, right? And so here we have a key B, A, B, and C. Now, notice the keys in object 2 are not, don't collide at all, right, with the keys in object 1, right? So object 2 is just fine, right? You just end up with the combination of the properties in object 1 with the properties in object 2. But here's another example, object 3, there is a collision, right? Because both object 1 declares a B, but object 3 also has a B. See that? And again, the keys need to be unique. So the question is, well, what is the result? And the result is basically last one wins, right? So for instance, if you copy these over here, you end up with A1, B2, C3. But then there's another B afterwards, right? That gives it a 4. So B ends up being 4, not 2. Make sense? Right? And so, and there's absolutely going to be several questions on the quiz, right? About, spreading and things overriding each other, blah, blah, blah. And then at the end, I'm going to ask you, well, what did B end up being, right? But if I switch this around, right? If I say instead, object, say 4, right? And then I put object 1 at the end. Okay, then the question, well, what does B end up being? Okay, well, because object 1 is being spread after, right, the B of 2 that brings this over is going to override my old B4. So it's on being that B is 2. So here, this ends up being that B is 4. This one ends up being that B is 2. Make sense? And so let's stringify the last one, object 4 here. And so let's bring that over and let's include in our JavaScript a spread, right? So it's spread. And there it is. See that? So B ends up being 2, whereas this B ends up being 4, right? And these end up being at the end, right? So this ends up being 1, 2, 3, 1, 2, 3, right? This ends up being the 1, 2, 3 are in the middle. See that? Ends up being in the middle. And so here's object 1 that is being spread over object 2. There it is at the beginning. And here they're being spread at the beginning, but then B overrides this B4 overrides the B2 here, right? And now it's spread at the end. We see that B2 gets overwritten, B equal 4 gets overwritten by B equal 2, and that's the result. Make sense? All right. All right, destructing. Okay, so destructing is the opposite of constructing, right? So constructing is the act of creating data structures, right? You're collating, right? You're putting different properties and values, right? And you're putting it together, building a complex data type. Yes, that's exactly what we did here, right? We brought in a whole bunch of properties, right? We put them together, right? And now we have a single object. Well, what if you want to go the other way around? You have an object, right? Maybe you have this object, and you want to destruct it. You want to deconstruct, right, into its constituent parts, right? So that operation is called destructing, right? So that if you have an object, right, that already has properties and values and whatnot, you want to destruct. You want to take apart all its individual constituents, right? Like each one of the properties. Well, you can use the curly operators on the left side of the equal sign. So the curly operators on the right-hand side build an object, right? Whereas the curly brackets on the left side of the operator of the equal sign, right, destruct an object, right? They extract from an object. It picks out those property and the value. So what this is doing is declaring two constants, name and age, right? And the values of those constants are, whatever values were for the, corresponding properties of the object. So it ends up being the name is John, right? And age is 25. So you are retrieving the original properties that you used to build the object originally, right? But you can also do it for arrays. So in arrays, it's different, right? In objects, it's by the name of the property, right? So these are the names of the properties. You don't have that in arrays, right? In arrays, you just have the values of the array, but you also have the index in which they are in, right? The order in which they are in the array. And that's what the destructing is based on, right? So for instance, here you have an array, and then you can destruct it, right? And so, but there's no property. There are no keys. The keys are the position, right? So there's position 0, position 1, position 2. So here, notice that the curly bracket, the square brackets are being used on the left side of the equal sign, right? So just like before, right? The square brackets on the right side build the array, but the square brackets on the left side of the equal destruct the array, right? It decomposes it into its constituents, which is the first item, the second one, and the third, right? And so first here, because it's in the position 0, gets the value of the element in position 0. And since this is in the position in position 1, right, it gets the next one, and it's by order. Make sense? So yeah, let me just build it out for you. So destruct, right, and let's paste it in there, and so destructing, it just displays the first, the second, and the third, which are going to be 1, 2, and 3, right? And then it displays the age, right, the name that was destructed from the object. So let's include it in our JavaScript. So we have here destruct, so destructing, right? And so there it is. So we have John 25, and then the values of each one that was destructed from the original array. Okay. All right, and finally, function destructing, right? Function destructing uses the destructing syntax, but within the context of a function, right? Which is, we already used this, right? We already used this when we were building the JSON script. See pre here? Notice that syntax, right? So that curly bracket used in a function, basically what it's doing, right? It's destructing an object that is being passed to it. So somebody's passing it an object, okay? And what it's doing, it says declaring a new variable called JSON that has the value of the JSON property in the object that is being passed as an argument, right? So it destructs it and assigns the value to JSON. See that? So yeah, so let's take a look at the exercise. So the exercise, right, creates a couple of functions, right? So it creates the add function, and then, just calls it, with 1, 2. So this is the regular way you pass parameters to a function, right? You pass parameter 1, parameter 2, right? And then A and B are bound to 1 and 2. But here's subtract. So subtract here is instead receiving a single parameter, meaning it's expecting an object as an argument, right? And then what it's going to do, it's going to take that object that is you're passing it as an argument, and it's going to destruct it, right? It's going to decompose its original properties, A and B, right? And then it's going to assign those values into these new variables A and B by destruction, right? And the way we use it is that we call subtract not with 2 arguments for A and B. We pass 1 argument that is just an object. It's an object that has properties A and B, which when the function receives it, right, it destructs and it declares, the A and B with the values 4 and 2. Make sense? So yeah, so let me demonstrate so we can create this function destructing, right? And we can just paste the result here, and we can then render it here, right? So this is function, what is it called? Function destructing. So function destructing. There we go, right? And there it is. So A and B, right? We're passing and then we pass the sum, which results in the summation of 3. Or here we're passing instead the A and B, right? Which are then destructed into the new variables A and B, and then subtracts them, and then you get the difference of 4 minus 2 is 2, what you would expect. Okay. So anyway, that syntax right there, right? We're going to use that syntax a lot this semester, right? So yeah, so all these exercises are meant for you to practice these, small little skills set, right, of understanding them in their purest form, right? And then when we get into using them in React.js, you'll see that we can use them quite a bit, as we build components, and we can pass parameters and do destruction and do spreading and do all that. Right? It's going to be a very, very common, as we now we're going to start applying all these skills, right, to building something. So the next thing would be, discussing, how do we use all these skills, right, to implement a single page application. Okay. Anyway, that's all I had for you today. Yeah, so that's a good question. Yeah, so a good question is that these extensions, right? Another common way to name these files is with .jsx, right? And that would be entirely valid. Yeah, you can absolutely use that extension instead, right? And it would be perhaps a little more descriptive, right, to the expectation that indeed, this is not pure JavaScript, right? But it is JSX. So absolutely, Tian. Is there any advantage of using single objects as parameter in subtract instead of passing A and B? Well, in that particular example, no. But you might have functions that you don't need to pass all the arguments, right? So if you're using this syntax, right, and you want to pass a variable number of parameters that maybe some of them are optional, right? So it's harder to implement using that syntax, right? As opposed to if you're passing an object, you just don't pass that. You don't pass a particular property, right? You only pass maybe a subset of those properties. So it's easier to have optional properties. Also, the syntax forces you to pass the parameters in a particular order, like first variable A, then variable B, in that order. Whereas this allows you to have B first, right, and then A. It doesn't matter. The order doesn't matter, right? So in that sense, it's more flexible, right? When you're passing parameters using objects, and you can also do validation as well, right? You can validate that the object is a particular data type, right? In particular, you can do all sorts of other things. Yeah. Right. Anything else? All right, folks. Thank you very much. So please, make use of all this source code. I'm going to push it now. Feel free to take it as yours, right? And so I think we were able to get through, maybe a third of the assignment, and most of it was copying and pasting from the code that was provided from the assignment, and so I'm going to perhaps trying to give you more starting code so you don't have to start from scratch, and be able to work a little more efficiently, and you'll get more out of it. Okay. All right. Excellent. Thank you, everyone. Good night.